Today we're going to talk about solving quadratic equations, and we're going to talk about two methods. But before we do, let's remind ourselves what the standard form of a quadratic equation is. Yes, we've talked about it before, but it's really important, so we just keep talking about it. Actually, I didn't want y equals. We're going to start with ax squared plus bx plus c equals 0. That is our standard form. A, of course, cannot be equal to 0. Because if a was 0, I wouldn't have a squared term. Wouldn't be quadratic anymore. So, quadratic equations can be solved in many ways, two of which are graphing and finding square roots. Now, you need to pay attention in this when we talk about the different ways of solving. There are, as we said, many ways to solve it. You got to pay attention to the directions and be able to follow the directions to know what method to use. Oftentimes it doesn't matter by what method you do something, but this is one of those cases where the method does matter. So we're trying to make sure you understand the process. So to start off with, and the main thing that you want to remember about solving by graphing is that the x-intercepts show you the solutions to the equation. So I put it right here in a box for you to emphasize, make it easy for you to spot whatever you need to do. If you don't have a highlighter, you can just do something around the box to make it stand out on the page. So you remember, when you look at a graph, the x-intercepts, and of course that is where they cross the x-axis. So that's an x-intercept, and that's an x-intercept. And that number is 1 and -1. So I will say that the solutions of the equation are x equals plus or minus 1. So at our second graph, where does it cross the y-axis or touch it? Excuse me. Where does it touch or cross the x-axis? And that is at 0. So x equals 0. In this graph, where does it touch or cross the x-axis? And it never does. So we say there is no solution. Okay? Moving on to another type, or in the same aspect. Those are given graphs. Sometimes they say what are the solutions of the equation, and they want you to graph the related function. So if I am graphing the related function for x squared minus 6 equals 16 equals 0, then I need to graph x squared minus 16 equals y. And we talked about this in a previous section, okay? And actually it was the first section that we did, and what we knew was that when it looks like this and we don't have a b term, we knew that our vertex was at 0, -16. So we plot the point 0, -16, okay? We also remember that our axis of symmetry goes through our vertex. So that's my axis of symmetry. And from there, we had our key points, which were 1, 2, 3, 1 squared, 2 squared, and 3 squared. And from my vertex, and then we looked at their a value, and a is 1, so I don't need to change those. And that's going to be my over and up from my vertex. So starting at my vertex, if I go over 1, notice my scale is by 2's. So over 1, I'm going to go up 1. What do I have? It's going up. It's going up by 4's here. So I may skip that point. It's going to be kind of close. Let's do that. We'll go over 1, up 1. If I go over 2, I'm going to go up 4. If I go over 3, I'm going to go up 9. Let's go ahead and put 4 on there because I got kind of a big graph. 4 squared is 16. So if I go over 4, I'm going to go up 16, which is going to put me here. And remember, we always count back to our axis of symmetry. So that's 1, 2 tick marks, 1, 2 tick marks. So once you're on a grid, you don't have to be exact about where that point is. It's halfway. So that's 1.5. So go 1.5. This is 1 tick mark. I'm going to go 1 tick mark. This is a half of a tick mark. I'm going to go a half. And then we're going to do our best to connect these points. But most importantly, when you connect them, what are we looking for to answer the question? What are the solutions of the equation? And the solutions of the equation are the x-intercepts. So for this problem, what I want to write in my answer blank is x equals plus or minus 4, because that's where my graph crosses the x-axis. All right, let's look at our next one. And this one, 3x squared plus 6 equals 0. Again, we're thinking about 3x squared plus 6 equals y. It's in that same format, so hopefully you recognize that the vertex is at 0, 6. So I'm going to go ahead and go up to 0. What am I? I'm going by 4s again. So that's 4, and halfway between 4 and 8 is 6. My axis of symmetry is the vertical line through my vertex. And now we're going to go down and talk about our key points. All right, my key points 1, 2, 3, 1, 4, 9. What's my A value this time? Hopefully you see that A is 3 because it's the coefficient of my x squared term. And that means, as we have discussed, that we're going to multiply each y value by 3. My x value doesn't change. 3 times 1, 3 times 4, 3 times 9. So they're all positive, so that means I'm going to go over from my vertex and up from my vertex. So from my vertex, if I go over 1, and this one's by 2, so over 1 is halfway, I'm going to go up 3. 1, 2, 3. If I go over 2, I go up 12. So I'm at 6. Up to 12 is going to be here. And if I go over 3, I'm way off my graph, so I'm not going to graph that point. From this point, count back. 1 tick mark, 1 on the other side. Half of a tick mark, half on the other side. So I'm going to connect them. Trying to make that bottom one curve as much as possible. We don't want to make it pointed. Now, what is the solution to my equation? Where does it cross the x-axis? It never does, so I have no solution here. All right, look at C. C is a little different because it's not equal to 0, so we need to make it equal to 0. X squared minus 25 equals negative 25. We're going to add 25 to both sides, and that gives us x squared, oh wow, equals 0. So we're actually looking to graph y equals x squared. Well, that is what we're always doing. So if we go 0, if I go over 1, I go up 1. If I go over 2, I'm going up 4. These are my original key points. This is my parent function. If I go over 3, I'm going to go up 9. If I go over 4, I'm going to go up 16. You know what? I was going ahead and graphing the points to the axis of symmetry, which I didn't even plot. Kind of got excited. It was that parent function. We didn't have to think so much to graph it. So to graph, put it together a graph, trying your best to go through all those points. And where does it cross or touch the x-axis? Hopefully you can see that's at x equals 0. Okay, so that is solving by graphing. Let's go solve it using square roots. I gave you the steps. We have our original equation, 3x squared minus 75 equals 0. So, of course, you would copy that down onto your paper. Now, you want to isolate the x squared. So how do we do that? Hopefully you remember from your solving of equations, we're going to add 75 to both sides. That gives us 3x squared equals 75. My x squared isn't isolated yet because I still have a 3 there. So I have to divide by 3. And now I have x squared equals 25. Okay? And what you're going to do this time right here is we're going to take the square root of both sides. So the square root of that side and the square root of this side. We have to do it to both of them at the same time. And when you do that, your answer will be plus or minus 5, because the square root of 25 is 5. And of course, negative 5 times negative 5 gives you 25 as well. So whenever you take the square root, it's always very, very important that you remember to put your plus or minus. And you can see from any related graph, if you did go and graph that equation, you would find out the same thing, that it will cross at positive and negative 5. So let's go do some algebraically. And to start off with, we have to isolate our squared term. So I'm going to add 36 to both sides. And that gives me m squared equals 36. So I take the square root of both sides, and m equals plus or minus 6. Alright, next I have 3x squared plus 15 equals 0. So we're going to subtract, because we're trying to isolate that x squared term. 3x squared equals negative 15. Divide by 3. And x squared equals negative 5. Now, if you put that in your calculator because you didn't recognize something, your calculator is going to tell you error, because you cannot square any number and get a negative number. It's impossible. So two positives can't give you a negative, and two negatives can't give you a negative. So the answer that we have here is no solution. All right, the last one. 4d squared plus 16 equals 16. So I'm going to do the opposite and subtract 16 from both sides. 4d squared equals 0. Divide by 4. And d squared equals 0. So what's the square root of 0? Punch it in your calculator if you don't know. It's 0. And again, this is just like the graphs that we saw. This one is tangent to our tangent, meaning it's only going to touch it one time. So wherever this is, it's looking something like this. Only touching my graph one time. Okay? This one over here, okay, we had something similar. It's going to not cross that x-axis. No solution means the parabola will never touch the x-axis. And over here, okay, if we had graphed it, we would have something similar to this, and these would be our points of intersection. So you get the visual along with the algebraic. All right, that's the end of the lesson. I'm actually going to go on and do some sample problems, some more graphing, and some more algebraic if you want to continue to listen. Okay, so now I'm going to do a few examples of each section, of each type that we just did, so that if you need some more examples to look at, then you'll have some to watch. So I have 8, 10, and 12. We're supposed to solve each equation by graphing the related function. If it has no real number solution, write no solution. I'm okay with, if you want to write no solution, you can. I'm also okay with the symbol, the null set, where you have a 0 with a slash through it. My slashes aren't doing so well there. Okay, so we have x squared minus 9 equals 0. My related function is x squared minus 9 equals y. And as we talked, that means our vertex is at 0, negative 9. So I'll plot that point, 0, negative 9. And then my a value is 1. So that means I get to use the key points as they are. 1, 2, 3, 1, 4, 9. So from my vertex, I'm going to go over 1, up 1, over 2, up 1, 2, 3, 4, over 3, up 9, which is enough because remember when we're solving it by graphing, we're actually looking for where it crosses the x-axis. So if we reach the x-axis, then I'm good. I'm going to count back over to my line of symmetry, which remember goes through my vertex always. So 1, 2, 3, 1, 2, 3 is the other point. 1, 2, 1, 2, and 1, and then 1. So my graph is going to look something like this. And what we're interested most in is exactly where it crosses the x-axis. So hopefully you can see from that that x equals plus or minus 3. Those are the solutions. All right, let's look at x squared plus 4. And this one, that gives me the related function is going to be x squared plus 4 equals y. My vertex will be at 0, 4. So I'm going to go graph 1, 2, 3. There's my point 0, 4. This is my axis of symmetry, so we label it. Sometimes it's hard to see it. My A value, again, is 1. So my key points are going to stay 1, 2, 3, 1, 4, 9. So from here, I'm going to go over 1, up 1, over 2, up 1, 2, 3, 4. Now, that should be enough to let you know when I count over 1, 2, 1, 2, count over 1 and over 1, that I'm not going towards my x-axis. So when I graph this thing, okay, kind of missed those points. Let's try that one more time. Okay, you want to use your eraser. If you don't get the points, you need to use your eraser. I have an undo button. So I graph my parabola. Where does it cross the x-axis? It never does. So that means this would be no solution, or using the symbol for the null set. Okay, the last example I'm going to do, actually I'm going to go look and see if I have one that I like better. That might be a little more challenging. We've done some of these. Let's go with, let's look at 14. It says 1 half x squared plus 1. Except for any of yours have fraction, there's one that's similar to 13 that you'll work. So let's do 1 half x squared plus 1. So I'm going to cross this one out. And I'm going to do 1 half x squared plus 1 equals 0. And what number was that? That was number 14. Okay, so just because these were a little too similar, I wanted to do one of a different type. Okay, so my related function will be 1 half x squared plus 1 equals y. So my vertex is still going to be 0, 1. And my A this time is 1 half. So that means I'm going to take those key points and I'm going to steal them from here instead of writing them again. But you could write them again if you needed to. And know that my x's will stay the same, but I'm going to multiply each y value by 1 half. So 1 times 1 half is 1 half. 4 times 1 half is 2. And 9 times 1 half is 9 over 2, or 9 halves, 4 and a half. So if we plot those points, I have my point 0, 1. We already plotted. If I go over 1, I go up a half. If I go over 2, I go up 2. If I go over 3, I go up 9 halves, which is 1, 3, 4 and a half. Count back to my line of symmetry, which is x equals 0. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 1. So hopefully you can see we're just going to go a little bit past that point the last point that we graphed. Because I don't know where it crosses the next one. Again, I'm looking for where it crosses that x-axis and it doesn't. So again, I have no solution. But just to give you another example of how to graph. So that's examples. Now let's look at it algebraically, and then I will stop. Solve each equation to find square roots. If the equation has no real number, write no solution. Okay? Remember, the key to these problems was to make sure that you isolate your squared term, your square. Okay? So, that's your x squared, your n squared, your w squared, k squared. Whichever term is squared, you want to get it by itself. And once it is by itself, you take the square root of both sides. So I have n equals plus or minus 81. 24, I'm going to have to add 36 to both sides so I can have w by itself. So w squared equals, negative 64 and 36 is going to give me 28. So we'll put that in our handy dandy calculator. Again, where are my students when I need them? The larger number is negative, so my number here is going to be negative. W squared equals negative 28. If you try to take the square root and put it in your calculator, you'll find out that it will say you can't do that. So make sure you know what your calculator says when you do, and you can't take the square root of a negative number. So this would be an example of no solution. All right, and our last one, again, isolating the variable. We're going to add 196 to both sides. K squared equals 196. I take the square root of both sides and find out that K equals plus or minus 14. So there you have it, solving quadratic equations by our two methods of graphing, finding the x-intercepts, and algebraically.